Hello everyone, today what I'll be doing is I'll be showing you how to find derivatives using the limits definition of a derivative. And I'm just going to jot it down so that you can see. So we said f prime of x, meaning the derivative of f of x, is equal to the limit as h tends towards 0 or approaches 0 of f of x plus h minus f of x, and all of that divided by h. Okay, so we have this definition over here. Now, let's say we want to find the derivative of f of x when f of x is equal to x squared. Okay, what will it do? Well, what we're going to be doing here is, the way we approach this problem is, we just write the limit as h approaches 0 of x plus h, and then squared, because that's a new input, that's a new x, because you see the parameter here is x plus h, so we want to have the same kind of thing, but I have all of this squared, because that's our function. Our function is x squared. X is the input now is x plus h, so we do that squared. Okay, so what we do now is that minus the function itself, which is just x squared divided by h. And how can we find this? So the first thing that's always a good idea to do is just expand brackets. So, you do that in regular algebra as well, so shouldn't be anything new in here. So we know that is the same thing as the limit as h tends to 0 of x squared plus 2 hx plus 2hx, and then plus h squared, all of that, minus x squared. I don't know why I put the brackets, it's just to show you that those are two different terms, which I just formed here. And then, even regardless of the limit expression over here, we just know that x squared and minus x squared cancel out. And we know that if we have both terms here, which are basically multiples of h, then we know it can cancel it out as well to form a more nice kind of expression here with no h's in the denominator, so that you just have one term over here. And then what you're left off with is the limit as h tends towards 0 of 2x plus h. And that's actually really interesting, because what did we say about h? H approaches 0. So at 0, h is equal to 0. And then 2x plus 0 is equal to 2x. So this is our limit. This is our first fully kind of completed, walked out derivative using the limit definition. It's a very useful one. Also, one day when you will teach calculus to someone, this is the go-to example, because it's so neat and so elegant. And yeah, just gonna put a smiley face because it's exciting. Okay, but now let's think of a more generalized form, because we know that x squared, the derivative of that, prime of that, is 2x. But this is far from being a generalized form, right? This is just it's just a quick example. So now I'm just gonna think, how do we find a generalized form for that? Well, how about instead of just forming the derivative of x squared, we're going to take the limit as h approaches 0 of f of x plus h minus f of x over h when f of x is equal to n times x to the power of n. And, or actually n, because it's two different numbers. So we're going to be doing that next video, and this is just going to be like, you know, a more generalized pure form, which will actually turn out to be something known as a power rule. I'm just going to give you a little spoiler here. What you saw here, that's because the power rule says that for any n times xn, the derivative will be mn x to the power of n minus 1. Sorry for running out of space. So yeah, we're gonna prove it in the next video. So yeah, have fun, and see you next video.